Hello students. Today, we begin the first topic under General Properties of Matter, Elasticity and Pressure. Let's start with elasticity. Elasticity is the property of a material by which it returns to its original shape and size after the removal of a deforming force. For example, a steel wire returns to its shape after being stretched, so steel is elastic. But materials like clay or wax do not regain shape. These are called plastic materials. When a force is applied to stretch or compress an object, it develops a restoring force to oppose this deformation. This restoring force per unit area is called stress. It is given by the formula stress equals force divided by area. The C unit of stress is the Pascal, which is 1 Newton per square meter. Now we come to stress. Stress is the internal restoring force per unit area produced in a material when it is deformed. We define stress as force divided by area. Its unit is Pascal, which is Newton per meter square. There are three types of stress. 1. Longitudinal stress, when force is applied along the length. 2. Shearing stress, when force is applied tangentially. 3. Hydraulic stress, when pressure is applied equally in all directions, like in fluids. Next, let's understand strain. Strain is the ratio of change in configuration to original configuration. It has no units and no dimensions. Strain is also of three types. 1. Longitudinal strain, which is change in length divided by original length. 2. Volume strain, which is change in volume divided by original volume. 3. Shearing strain, which is the angular deformation in radians. Now comes Hooke's law. According to Hooke's law, within the elastic limit, stress is directly proportional to strain. That means, if you apply more force, the material deforms more, but only up to a certain point. The proportionality constant is called modulus of elasticity. Let's now discuss the elastic moduli, which are 4 in number. 1. Young's. 2. Bulk. 3. Shear, rigidity. 4. Positions ratio. First, Young's modulus. It is defined as the ratio of longitudinal stress to longitudinal strain. In simple words, it measures stiffness of a material when pulled or compressed along its length. Second, bulk modulus. Bulk modulus is the ratio of change in pressure to the fractional change in volume. It measures how resistant a material is to uniform compression. The formula is bulk modulus equals minus change in pressure divided by change in volume upon original volume. The negative sign indicates that when pressure increases, volume decreases. Liquids have high bulk modulus because they are nearly incompressible.
Sir, does that mean water has a high bulk modulus?
Yes, very good question. Water resists compression, so its bulk modulus is high. Third, modulus of rigidity, also called shear modulus. This is used when a body is subjected to tangential force. It is defined as shear stress divided by shear strain. Fourth, Poisson's ratio. When a wire is stretched, it becomes thinner sideways. Poisson's ratio is defined as negative of lateral strain divided by longitudinal strain.
Where do we use elasticity in practical situations?
Great question. Let me give you some real-world examples. Railway tracks are laid with gaps to allow thermal expansion in summer. Bridges are mounted on rollers or use expansion joints so that they don't crack when the temperature changes. Bimetallic strips are used in thermostats. These bend when heated and are used to control circuits. Z. Springs store and release mechanical energy. Electric wires are left loose to adjust for temperature-related expansion and contraction. Let me give you a numerical example. Example, A wire of length 2 meter and cross-sectional area 1 millimeter square is stretched by 1 millimeter under a force of 200 Newton. To find Young's modulus, use the formula force into original length divided by area into extension. So, 200 into 2 divided by 1 into 10 raised to the power minus 6 into 0.001. This gives you 4 into 10 raised to the power 11 Newton per meter square. Now we move to pressure and hydrostatics. Pressure is defined as force applied per unit area. It is measured in Pascal. It is a scalar quantity. Thrust is the total force acting normally on a surface. Thrust is a vector quantity. Its unit is Newton. Hydrostatic pressure is the pressure exerted by a fluid at rest due to the force of gravity. It increases with depth in the fluid. The deeper you go, the higher the pressure. Example, at a depth of 20 meters underwater, with density of 1000 and gravity 9.8, pressure is 196,000 pascals.
Sir, then why do dams have a wider base?
Good question. Water pressure is greater at deeper levels. So the base of a dam is made wider to resist that greater pressure safely. Now comes Pascal's law. It says that when pressure is applied to an enclosed fluid, it is transmitted equally in all directions. This principle is used in hydraulic machines like hydraulic lifts and hydraulic brakes. Let's now talk about the barometer. A barometer measures atmospheric pressure using mercury. At sea level, the height of mercury is 76 centimeters. This corresponds to 1.01 into 10 raised to the power 5 pascals.
Why does water boil faster in the plains than in the hills?
That's a very smart cue. At higher altitudes, atmospheric pressure is lower. So water boils at a lower temperature. This is why cooking takes longer in the mountains. That's all for today. We have discussed elasticity, Hooke's law, types of elastic moduli, real-world uses of elasticity, pressure, hydrostatics, and Pascal's law. In our next session, we'll cover buoyancy, flow of fluids, and viscosity. Jai Hind.